This is the final project demonstration for Team 5 Spring 2020 Fundamentals of Software Engineering. We built a multi-user paint program and we'll be walking through its installation, compilation, and features in this video. Before we run our program, we need to have a library called Simple Fast Media Library, or SFML, downloaded onto the local machine. Begin by taking a look in the build.md file for details on how to download and configure this library. Now, to get our project onto your local machine so that you can run it, go to our GitHub and clone the download link. Then navigate to the source/bin folder. From here, you can compile and make an executable of our program. To do this, run the command cmake space ... which uses a cross-platform file that will generate a makefile that will compile and link all necessary files and libraries to run the program. This CMake file is platform agnostic, meaning it is configured to be able to generate the necessary executable whether you are on Linux, Mac, or Windows. Once you've run cmake space ... run the make command. If you're on Windows, you'll finish the build process using Visual Studio. Anyways, make will generate our executable, which will be run with /app or just app if you're on Windows. At this stage, a user can compile our program in either the normal or debug mode, but the makefile will need -d_debug depending on whether or not you as the user want to see the flow of control of the program with associated print statements.
Once all clients are connected to the server, or if a user simply wants to paint for themselves once they have a paint window with GUI open, we can begin using our canvas. A client can use the following actions. They can select different colors using the keyboard buttons 1 through 7, or select colors in the GUI window. After selecting a color, they can click and drag on the canvas to draw a line. They can also fill an entire canvas with a selected color by hitting the space bar or enter. Undoing any of these previous commands can be done by hitting Z, and redoing commands is done by hitting Y. After any one of these actions is used, the command object is parsed into a unique string that's sent to the server. The server then broadcasts that parsed command string to each of the clients. The clients receive the parsed string and turn it into a correct command, and then it's executed on the client's canvas. If a user connects to a session with commands already having been performed on the canvas, that connecting client will be sent all the commands from the server to enable the new client to catch up.
Another couple of extra features that we implemented include a chat feature and a rainbow brush feature. To chat with other users, a user can go to their paint window, hit the keyboard button C, and then type their message into the terminal. This message will be sent to the server, and all receiving clients will have that message printed to their terminal, along with the sender's username. For our rainbow brush feature, a user can go to their GUI, select the rainbow option, and then paint on the canvas using the unique brush. This brush will make the line drawn on the canvas cycle through the colors of the rainbow to create a spectacular effect. This is the functionality of our application in its entirety. Though we use additional technologies like Doxygen to create comprehensive documentation and GitHub Actions to create a continuous integration assurance. If a user wants to know more about a particular function or class, they can go to the provided Doxygen documents through our online module. On this website, a user can see the architecture of the program, all the classes with their respective inheritance, and comments on different functions and classes. To ensure that any and all new code is compatible with previous versions of the program, our CI in GitHub Actions automatically runs tests on that code. This is helpful as it lets us maintain the test code with every iteration we push to GitHub.